Welcome everyone to today's video. We are going to do question number 1. This came in JEE Advanced 2019, paper 1. Question being, okay, there is a spherical gaseous cloud of mass density rho r. Each particle in this gas cloud, let's say the particle is having mass m, has the same kinetic energy k. Question is, what is the density of the gas cloud as a function of radius and the corresponding particle number density? That's what we want to find. So we can take heart from an equation. Uh, as per that equation, the density of such gaseous planets is simply 1 upon 4 pi g r d by dr of g r square. So this is an equation which you can remember, uh, that the density is this particular expression depending upon the action of gravity and the radius of the point from the center of the planet. We can find the density. Here it is given that the kinetic energy of the planet is same, so kinetic energy of the particles is same, so we can now use Newton's second law, that is mv square by r, centripetal force acting on the particle, is equal to gm small m divided by small r square, is the gravitational force. So we can say v square by 2 is equal to half gm by r square. So this is nothing but the value of small g, gm by r square. This is the value of action to gravity at a point r. Here m mass is basically the mass of the planet within this shaded area, that is within the surface of the region bounded by that r radius. So that is the only thing required. So after substituting that, we can multiply this with m as a precursor and say that, okay, this whole quantity is constant. So this value g is also going to be constant and it's going to come outside. So basically the expression is going to become 4 pi g r square uh, 2k by m and d by dr of r square. Here 1 r is there, uh, v square by r was there, so since r we have cancelled here, this r will get cancelled, so we have to multiply 1 r here. So this would be r cube. If we substitute g, it would be g by r. So this expression would become k upon 2 pi g mr square, and this r, you can say, came from here. This r, it came from the expression of mgr. So option A is the correct one. Question number two, we'll discuss in the next one. There's one more approach to do this one, which is basically differentiating this particular expression, that is mv square by r is equal to gm small m by r square. You can differentiate this particular expression with respect to small r and say that v square is a constant. So again, you will be able to get the same thing which we are having, and then you will write that mass m, dm mass is equal to 4 pi r square dr into rho density. So from here you can find density after differentiating m with respect to r here. You can substitute that here and you'll get the same answer. So thank you.